Hello guys! Welcome again to our second session, second class in General Mathematics. We are now on week 2A. Our topic is about real-life situations using rational functions. And the objective of this is, at the end of this discussion, the students will be able to represent real-life situations using rational functions. What is a rational function? A rational function, f of x, is a function that can be written as f of x equals p of x over q of x, where p of x and q of x are polynomial functions. The domain of f of x is a real number except for those which q of x equals 0. We have here our example number 1. On any trip, the time you travel in a car varies inversely with your average speed. The function t of s equals 60 over r models the time in r it will take you to travel 60 miles at different rates of speed r. How long would it take to travel with 15 miles per hour, 20 miles per hour, and 20 miles per hour? So we are looking for the time here. So let's just substitute the value of r to our equation. So t of s is equal to 60 over, first given is 15 miles per hour, 15. So it will take 4 hours. Next is t of 20. So that is 60 over 20. 60 divided by 20 is 3, so it will take 3 hours. And last one is t of 25 miles. So that is equivalent to 60 over 25. And that is equal to 2 hours. And that's 10 over 25. Or that is 2.4, I think. 2.4 hours. Let's try to check if 60 divided by 25 is, yes, that's 2.4 hours. Or that is, how much is 0.4 hours? That's 4 times 6. That's 2 hours and 24 minutes. Okay, so let's continue. The family decided to go to a travel destination which is 500 kilometers away from your town. So it is given that the distance is equal to 500 kilometers. How long will it take to get to that travel destination if your car's average speed is 25 kilometers per hour? So we know that the distance is equal to rate times time, and so since we are asking for the time, our time is equal to distance over the rate. So 40 kilometers per hour, 50 kilometers per hour, and construct a function t of s that describes the time it takes to drive from your town to your travel destination. So since we have this one here, we can also use t of s equals, the distance is 500 over the rate. Okay, and so we can answer this one, 25 kilometers per hour. So t of s equals 500 divided by 25. That is 20. So we have 20 hours. Next, t of s for 500 divided by 25. Next is 40 divided by 40. That is 12.5 hours. or that is 12 hours and 30 minutes. And lastly, T of S equals 50 kilometers. So 500 divided by 50 kilometers per hour, that is 10 hours. That is your answer for letter A. And so, a function T of S that describes the time it takes to drive from our town to travel to the destination, and let S be the speed of travel, must be this one. So this is the answer for your letter B, and this 3 are the answer for your letter A. Let's continue. Exercise 1. The formula I equals 445 over x squared. I is the intensity of light in lumens at a distance x feet from the light bulb with 445 watts. What is the intensity of light 5 feet from the bulb and 15 feet from the bulb? So this will be easy. All you have to do is just use this formula over x squared, where your x is the distance in feet. And so, first x is I of x is equal to, this one, I is equal to 445 over, first given is 5 squared, and the other one is I equals 445 over 15 squared. So we have 445, 5 squared is 25, and so try to solve it and you will get your answer. Next is, that is I equals 445 over 15 times 15 is 225. So your I will be equal to that one. So you can solve this one and this one in order to get your final answer. Let's continue with number 2. The Orange Company has a budget of 1 million to be divided equally among its offices x. So we don't know the number of offices. Construct a function g of x which would give the amount of money each office would receive. Take note that it stated that the 1 million pesos should be divided equally among the different offices. Okay, so since x is the number of office, so we'll have here 1 million pesos divided by the number of offices. So that's it. And if the company had 17 offices, how much would each office receive? So this time you are going to solve for g of 17. I think you are now able to solve that one. And also, how about for 23 offices? So you have to solve for g of 23. That is 1,000 divided by 23. Students, take note that this is not the final answer. This is just a guide on how you are going to answer your exercise on General Mathematics Week 2A. Okay, this one is an enrichment activity. A high school spends 25,000 each year on student academic achievement awards. The amount spent per award depends on how many awards are given. So write a function that models the relationships between the number of awards A given and the cost C of each award. How many awards are given if the cost of each award is 300 pesos? If there are 67 awards, how much is the cost of each award? Okay, so we have here A, number of awards, and your C as the cost of each award. Knowing that we have a given of 25,000 as the amount spent each year. So it depends upon on how many awards are given. So if we have 25,000 and first question is how many awards are given if the cost of each award is 300 pesos. So that will be 25,000 divided by cost of award. That will be the function of A. Function of A means that, it's not function of A. Function of C. Okay. Or this can be represented by A. A is the number of awards if the cost of each award is C. So we have here the C is equal to 300. And next one, we have how much is the cost of award if there are 67 awards. So if there are 67 awards, we are solving for the cost. That will be 25,000 divided by A, where your A is equal to 67. Okay, so that's it. You can try to solve that and find the final answer. Next is as radio signals move away from the transmitter, they become weaker. The function S of D equals 1,600 over distance squared relates the strength S of a signal at a distance D miles from the transmitter. For what distance is S less than or equal to 1? Find the signal strength at 10 miles, 1 mile, and 0.01 mile. Okay, so for this second question, the signal strength at 10 miles, so this one is already given. Let's try to solve for distance equals 10 miles, distance equals 1 mile, and also distance equals 0.01 mile. So let's try to substitute this one. I will answer this and you are going to answer this one. Okay, so that is 1,600 over 0.1 squared. And that is equal to 1,600 divided by 0.1 times 0.1 is 0.01. And 1,600 divided by 0.01, the answer will be 160,000. Okay, so we have to add 2 zeros here because we have 2 decimal places. So that is 160,000. That will be the strength of the signal given the distance 0.1 mile. So please try to solve for this one. D equals 10 and D equals 1. And also for the first question, for what distance is S less than or equal to 1? So let's try to substitute S as 1 here and equate that to 1,600 divided by D squared. At this point, since D is what we are looking for, you have to solve for D. Okay? All we have to do to eliminate your D squared here, we can multiply both sides with D squared. That's multiplication property of equality. So divide this one, it will cancel out, And what is left is d squared times 1, that is d squared, equals 1,600. Now, find for d. Okay, that is square root of your 1,600, and that is equivalent to positive blank. Okay, so you answer that one. We are done with quarter 1 week 2A, and let's continue with general mathematics week 2B. It is about distinguishing rational function, equation, and inequality. The objective of this is, at the end of this discussion, the students will be able to distinguish rational functions, rational equations, and rational inequality. So, remember this one. For a rational expression, it is an algebraic expression whose numerator and denominator are polynomials, and whose denominator is not equal to 0. So, the denominator must not equal to 0. For rational equation, it is an equation involving rational expressions. It means that it has an equal sign between the two rational expressions. For rational function, it is a function that can be written in the form f of x equals p of x over q of x, where p of x and q of x are polynomials and q of x is not equal to 0. And last one, the rational inequality is a statement that compares two rational expressions using these symbols: less than, greater than, less than or equal, greater than or equal, and the symbol not equal. So if you see these signs, you may consider it as rational inequality. If you see the equal sign, you may consider it as rational equation. Here are the examples of rational expressions. We have 1 over x, 3 over x plus 2. We can also have this one, x plus 1 all over x squared plus x minus 2. Or we can have this, x raised to 4 minus 16 all over x cubed plus 2. These are examples of rational expressions. Let's have rational equation. Take note that there is an equal sign and there is a rational expression in it. So we have here a rational expression, an equal sign, plus the value on this. We can also have two rational expressions having equal sign between them. We can have two rational expressions, same thing, with equal sign between them, and like this one. All of these are considered as rational equation. Next, we have here an example of rational function. You will notice that a rational expression is expressed as a function of f of x. Just like this one is h of x, this one is function y, and this one is c of x. And all of these are equal to a rational expression. And here are the examples of rational inequality. You will notice that we have here the inequality sign, and there are involvement of rational expressions. Those are rational inequality. So let's have here the exercise. Determine whether the given is rational function, rational equation, rational inequality, or none of this. Write your solutions in your answer sheet. Okay, in your answer sheet. Some of the students have answered in their notebook, but you can give your notebook to the centers, but just bring your answer sheet with your name. Some students don't put their names on the answer sheets on week 1, so don't forget to write your name there. So this one, since we have an equal sign and these two are rational expressions, we consider this as rational equation. Next, we have this one. We can say that this can be an inequality, but knowing that this can be considered as rational expression, so it is neither. Of the three. Okay, this one, since it is considered as a function of this rational expression, so this is a rational function. This one can be considered as rational inequality. And this is a rational expression and a rational expression, so it can be considered as rational equation. Okay, so we are done with determining rational equations or functions. Let's have our activity. Determine whether the given is a rational function, rational equation, rational inequality, or none of this. So try to observe this one. What is this? Okay, so what is this? This number 2 also, number 3, number 4, and number 5. I don't have to answer that because that will be an activity for you. Let's continue. We are done with quarter 1, week 2B, and we are now on week 2C. Okay, so solving for rational equations and inequalities. So our objective is at the end of this discussion, the students will be able to solve rational equations and inequalities. Remember, to solve a rational equation, the following steps may be used. Always determine the least common denominator of all rational expressions in the equation. Then multiply each side of the equation by the LCD. Take note, multiply each side of the equation by your chosen LCD and solve the resulting equation by applying different properties of equality. Check the solution by replacing each variable in the original equation. Okay? Also, to solve rational inequality, we have these steps. Rewrite the inequality as a single rational expression on one side of the inequality symbol and 0 on the other side. So take note of this first step. This is very important. Then, determine over what intervals the rational expression takes on positive and negative values. Locate the x values for which the rational expression is 0 or undefined, and make the numbers found in step A on a number line. Use the shaded circle to indicate that the value is included and solution set in the solution set, and the hollow circle to indicate that the value is excluded. So when can we say if it's included? It's included if we have the symbol greater than or equal, less than or equal. And it's not included or excluded if the symbol is just greater than or less than. This number partition the number line into intervals. You have to select a test point within the interior of each interval in step B, and the sign of the rational expression at this point is also the sign of a rational expression at each interior in the aforementioned interval. Summarize the intervals containing the solution. Okay, so take note that in multiplying or dividing both sides of inequality by a number requires that the sign, positive or negative, of the number is known. Since the sign of a variable is unknown, it is not valid to divide both sides of an inequality by a variable. So let's try to solve this one. First, step 1, we have to find the LCD. Okay, so let's factor this out. This one is factored as x minus 5 times x plus 3. X plus 3. Sorry. It's not x plus 3, but x minus 3. Okay. And so, the least common denominator for the three of these expressions can be x minus 5 times x minus 3. And it can be written wholly as this one. So, our LCD is x minus 5 times x minus 3. Actually, I have written and chosen this kind of LCD instead of writing it like this because it's easier for us to cancel if it's written like this one. Okay, so let's continue. Let's multiply both sides of this equation into our LCD. Okay, that is our step 2. So let's erase this first and multiply it with our LCD. This one multiplied with our LCD, which is x minus 5 times x minus 3. And same thing here on the right. You have to multiply it with the LCD, which is x minus 5 times x minus 3. And so, the answer will be, okay, all you have to do is cancel this one. This one will be canceled if you multiply it with this. So, we'll have 7x plus 3 over 1. Then, plus, you can cancel this x minus 5. And so, what is left is x minus 3. So, we have 3x times x minus 3. And that is equal to, if you try to solve this one, we'll have negative 1 multiplied by, cancel this, and you can have x minus 5. So that will be the answer for this one over your LCD. Okay, all over your LCD. X squared minus 8x plus 15. This one is x squared minus 8x plus 15. But then, you can just solve this one as 7x plus 3 plus 3x squared minus 9 equals negative x plus 5. Okay, let's try to solve for that one. We have 3x squared plus 7x. We'll have it here plus x. For after this one, we have finished this one, so we have 3 plus 3 minus 9 minus 5 equals 0. Then let's combine all the terms. We'll have 3x squared plus 8x. 3 minus 9 is negative 6 minus 5 is negative 11 equals 0. So I better try to check if that's correct. 3x squared plus 8x, 3 minus 9 is negative 6, minus 5 is negative 11. Because sometimes, because when I'm so tired and too sleepy, I have always errors in my computation. So let's try to check always. So what are the factors of this one? Okay, the factors of this one is, I think it's 3x in x. Then, in order to get your 11, we must have positive 1, plus a value and minus a value. So let's have here 11 times 1. So that's 3 minus 1 and x plus 11 equals 0. Let's try to check if this is the correct solution. So 3 times 1 is negative 3x. 11 times x is 11x. Does it result to 8x? Yes, it results to 8x. So therefore, this one is correct. And so, the value of our x is 3x plus 11 equals 0. So 3x equals 11, negative 11. Divide both sides by 3. And so x equals negative 11 over 3. This one is the first answer. And our x minus 1 equals 0. So our x equals positive 1. This will be now the values of our x. Let's continue with example 2. Let's solve this inequality. Notice that in inequality, you should transfer one part of the equation so that it will be equal or greater than to 0. So, we have To transfer this on the right side, we'll have 0 is greater than or equal to 1120 over x plus 10 minus, since this one is positive, it will become minus there, negative 1600 over x plus 4. Then we are going to find the LCD of this. What will be the LCD? That's x times x plus 4. So that is 0 greater than or equal to x times x plus 4. Now, first thing is we have to focus on this one. Divide x times x plus 4 with your x and multiply with the numerator. So if we divide this with x, the answer will be 1120. This one will be cancelled. 2 x's will be cancelled and we'll have x plus 4. Next is your 10. So 10, the denominator of 10 is 1. So x times x plus 4 divided by 1 equals x times x plus 4. And so we have 10 times x plus 4. And lastly, we have minus 1600 multiplied by x times x plus 4. Now you can cancel this one. And what is left is x. Okay, so let's combine this. This will become 1120x plus 1120 times 4 is 4,480. Is that correct? 4,480. And this one will be 10x. So 10x times x, that is 10x squared. And 10x times 4, that will be 40x. Then subtracted by 1600x. Now let's combine like terms. Okay, we have 10x squared. Then all the x's, we have 1120x plus 40x, so that is 1120 plus 40, that is 1160. Then subtract 1600x. That is 0, 4, 5 minus 1 is 4. So that is 440. So we now have negative 440x. And last one, we have plus 4,480 over x times x plus 4. And so if we are going to factor out, we can have 10 times x squared minus 44 plus 44x plus 448 all over x times x plus 4. This will be now the equation, but then you still have to factor this out. What do you think will be the factor of this one? 44, 448. 448 divided by 10. That's 44.8, no? Divided by 4. So how can we factor this out? We have to look for factors of 448 that when added will become 44. So 448 divided by, if we have 16 and 28, Okay, let's try 16 and 28. 6 plus 8 equals 4. Carry 1, 44. Okay, so we have 16 and 28 as factors. Okay, 16 and 28. Let's remember that. That will be 10 times x minus 16 times x minus 28 all over x times x plus 4. Now we can already have our test points. Okay, so let's have this one. Ten times x minus 16 times x minus 28. Okay, that will be our inequality now. Let's erase this first and solve for the test points. It must be greater than 0. So when we say greater than 0, we must make sure that the answer will be positive. So let's erase this first. And have our test points. So x minus 16 equals 0, so x equals 16. This one will be one of our point. X minus 28 equals 0, so x equals 28. This one will be another point. So on our denominator, we have x equals 0, and the other one is x plus 4 equals 0, so x equals negative 4. So we have how many test points? 1, 2, 3, 4. Okay, so let's try to see. Arrange that. So we have the interval for x less than negative 4. Then from negative 4 less than x less than 0. Then we can also have our 16, 0 less than 16 less than x less than 16. We also have this 28, 16 less than x less than 18, less than 28, and last one is x greater than 28. Those will be the test points. Okay, let's try to check. If we have x minus 16, x minus 28, x, and x plus 4. Then let's find out the result. The result will be here when this one divided by this one. So let's try to solve. If x is less than 4, we can take value negative 5. Negative 5 minus 16 is negative. We can take the value negative 3 here. Negative 3 minus 16 is negative. On this case, we can take 2. 2 minus 16 is negative. On this case, we can take 20. That's between 16 and 28. So 20 minus 16 is positive. Then greater than 28, it's obviously positive. We can use 30 here. Let's try with this one. Negative 5 minus 28 is negative. Negative 3 minus 28 is negative. 2 minus 28 is negative. 20 minus 28 is negative. And 30 minus 28 is positive. Let's have this. Negative 5, negative. Negative 3, it's still negative. When it's 2, it's positive. When it's 20, it's positive. And this one is positive. Next, x plus 4. So we have negative 5 plus 4, that's negative. If we have negative 3 plus 4, we get positive. If we have 2 plus 4, positive. This one is positive and positive. Let's find out the result. This will have positive value. When multiply, this will have positive value. When multiply, this will have positive. This one has negative. This one has positive. Positive times positive will be positive. This one has negative. This one has positive. Both of this will have positive. Then let's try to divide. Positive divided by positive, the answer is positive. Positive divided by negative will be negative. Positive divided by positive will be positive. Negative divided by positive will be negative, and positive divided by positive must be positive. So therefore, since we are looking for the value greater than 0, the interval will be this one. And what do you think will be that interval? Let's erase this one. So our solution set will be values for x less than negative 4, values from 0 less than x less than 16, and that's union x greater than 28. Okay, this is the solution set for the answer on this inequality, and also it can be drawn on a number line wherein you'll have your negative 4. Negative 4, since we have this value, or equal. We should use or equal because we have this symbol. And so, we have negative 4 less than negative 4. So, this one must not be hollow because negative 4 is included. And this is how we should draw it. Next is from 0. Suppose this is your 0. And also we have your 16. 4, 1, 2, 3, 4. Suppose this is your 16. This will be the next drawing. 0 is included, 16 is included, and you have to make this bold one. And lastly, we have 28 here. Let's put our 28 here, around here. Even if it's not accurate, you know that you'll have it there. So 28 is included. That will be the picture of your number line given your inequality. Okay, so let's have our enrichment activity. I'll just give you a tip. So we have our LCD. What is the factor of this one? It can be x times x minus 2. So therefore, since we have x here and we have x minus 2 here, this can be our LCD. X times x minus 2. Then, second step is multiply both sides with the LCD and cancel. So if you have canceled everybody there, you are now able to find the rational expression by factoring. To find the value of x by factoring. And also this one is an inequality, so you have to transfer your 4 to the left side of equation and follow the steps that I have discussed. Okay, we are done with quarter 1, week 2C. Let's have our week 2D now, representing rational functions. How are we going to represent rational functions? So objective is, at the end of this discussion, the students will be able to represent rational functions through its table of values, graph, and equation. Okay, so remember this, that the representations of rational functions can be equation, table of values, ordered pairs, and also graph. So let's have this one. Represent the speed of a train as a function of time it takes to travel 1,000 meters. So, since the speed of the train depends on the time it takes to travel 1,000 meters, we can represent speed as function of time. So let x represent the time. So our x is time here. It takes to travel 1,000 meters. The speed in the meter per hour can be represented as a function s of x. So we have here s of x is 1,000 divided by x, which is your time. Observe that the function above is similar to the formula of speed is equal to distance over time, relating speed, distance, and time. Rational function represented by table of values. Using scenario above, we can construct a table of values for the speed of train in various times. This will help us determine the behavior of the function as the variable x changes. So using this s of x equals 1,000 over x, where s of x is the speed in meters of the train and x as time in hours, we derive the following table. So if we have x as 1, we have 1,000, 10, 100, and so on until if we have 1,000, that is 1. So from the table of values above, we derive some ordered pairs, just like this one is your A, this one will be your B, and so on until you find your I. That's 1,001. And also, if you are going to plot the ordered pairs that we have, let's go back there. These are the ordered pairs, and if you are going to plot that into a graph, it will look like this one. These are the different representations of your rational functions. So let's have our exercise. Read and understand carefully. Write your solutions in your activity notebook or answer sheet. Again, write it on your answer sheet. Don't forget to write your name. Represent the rational function given g of x equals x minus 1 over x plus 1. Okay, using a table of values, ordered pairs, and graph. So you can make your own table. Suppose your x is this one, and your g of x is this one. You can make your own table of values there. Okay, you can use -5, -3, 0, +3, +5. You can have that, or you can use other values, and whatever is the g of x here, just substitute the -5 minus 1 over -5 plus 1. That is -6 over -4. That becomes positive 3/2. Okay, so we have here our g of x as 3/2. Then you can continue solving for that using the value of -3, 0, 3, and 5. Okay, so you will be the one to solve for that. And after that, you are going to make your own ordered pairs. Okay, this is for A, table of values. For B, we have ordered pairs. So our first ordered pair is -5, 3/2. If you put your answer here until here, you can have the other values there. And also, you can plot your graph here. Okay, I think you already know how to graph the values given the ordered pair. This is your y-axis and this is your x-axis. So please try to answer this one. And for our enrichment activity, read and understand and write your solutions in your activity notebook or answer sheet. It takes 250 work days to build a house for charity. For example, if 2 workers build the house, it takes them 125 actual construction days. If 10 workers are present, it takes 25 construction days to build the house. Write a rational function that represents the number of construction days to build as a function of number of workers. Also, provide its table of value, ordered pairs, and then graph the function. Okay? So, please try to do this on your own. We are now done with quarter 1, week 2D. And let's have our week 2E. Okay, this is the last one. The domain and range of our rational function. Objective is, at the end of this discussion, the students will be able to represent rational functions through its table of values, graph, and equation. Sorry, why is that so? I think it's wrong. Okay, so we have the wrong objective here. Let's go back there. At the end of this discussion, the students will be able to determine the domain and the range of the rational function. Okay, so let's remember this first. Domain is a set of first coordinates or the ordered pair possible values for the input or the independent variable of a function. Set of all possible values that the variable x can take, and the range is the set of second coordinates of ordered pair possible values of the output or dependent variable of a function, set of all values that f of x will take. So find the domain and range of this rational function. So first, let's find the domain. What is the value of x that will make this undefined? Okay, that will be the exception for the domain of this rational function. All we have to do is equate x plus 2 equals 0, because when this one will become 0, the rational function will become undefined. So x plus 2 equals 0, so x equals negative 2. So since this is our exception, it must not equal to negative 2. So the domain are the values of x such that x is an element of real numbers where x must not equal to negative 2. That will be the domain of the function. Now, let us find the range. Okay, so if we are going to find the range, let's substitute y here first. So we have y equals x plus 2. It's x minus 2 over x plus 2. So first thing is you multiply x plus 2 on both sides of the equation. So if we multiply x plus 2 on both sides of the equation, we have xy plus 2y equals, you can cancel this, x minus 2. Then all you have to do is put your x on the left side of the equation. So we have xy minus x equals negative 2y minus 2. So now we can factor this out. X times y minus 1, this is the factor of this one, equals negative 2y minus 2. And so divide both sides by y minus 1. Cancel this out. So our x is equal to negative 2y minus 2 over y minus 1. So if we use this one and equate this to 0, the function of x will be, the value of x will be undefined. So let's try. We have y minus 1 not equal to 0. So y must not equal to positive 1. So therefore the range is y such that y is an element of R. However, y must not be equal to positive 1. That will be the range of our rational function. Okay, so find the domain and range of the rational function below and write your solutions on your answer sheet. Okay, let's try this one. The domain must be, but this one is not a rational function, but I hope you know how to find the domain and the range of that. Okay, for this one, the domain must be x squared minus 4 must not be equal to 0. If we factor this out, we can have x plus 4 times x minus 4 equals 0. And so, not equal to 0. And so, our x must not equal to negative 4 for this one. And for this one, our x must not equal to positive 4. So we have two values for exception of the domain. So x such that x is an element of real numbers. However, x must not equal to negative 4 and positive 4. Okay, you can write it down like that. Okay, and let's find the range. Okay, let's have this as y equals 4 over x squared minus 4. Then, multiply both sides with x squared minus 4. So we have x squared y minus 4y equals, cancel this one, we get 4. And so, we have x squared y equals 4 plus 4y. This one will be transferred to the right side. And divide both sides by y. We get x squared equals 4 plus 4y over y. And find the square root of both sides of the equation. So x must be equal to positive or negative square root of 4 plus 4y over y. So at this point, our x must not be equal to this one. Sorry. The value of our x now is this one. And so, what is this? This is square root of 4 plus 4y all over square root of y. Okay, let's rewrite this. We have x equals positive or negative square root of 4 plus 4y over square root of y. Notice that this one are the values of x in terms of y. And so, if we have square root sign all over here, so we can put square root sign above and below square root of your numerator all over the square root of your denominator. And so, we can't have a 0 value here. Therefore, we can put 0 here. Okay, and also, we can't even put a negative value here because it will become a complex number. So the range will be y such that y is an element of a real number. However, y must be greater than 0. Why did I say that it must be greater than 0? Because we cannot use 0 here, it will be undefined. If we use negative values here, the answer here will be complex numbers or imaginary numbers. So the possible number that we can use, or the possible real number that we can use, are those numbers greater than 0. So let's try to check with our number 2. Number 2, whenever you see this kind of function, whenever it is a polynomial, usually the domain of it are all real numbers and the range of it are also all real numbers. Okay, you try to solve for the other numbers. Good luck, guys. And we also have this enrichment activity. Find the domain and range of the function and write your solutions in your answer sheet. So same thing will happen. For the domain, it must not equal to 0 here. So the domain is x, such that x is an element of real number, where x, if we equate this to 0, again, if we equate this to 0, that our x will become positive 3. So that is except, x is an element of real number where x is not equal to 3. That will be the domain of letter A. And for letter B, you can have it y equals x over x minus 3. Then multiply both sides by x minus 3. So we have xy minus 3y equals x. Then you can have it here, all the x's on the left. Xy minus x equals positive 3y. Then factor it out. X equals y minus 1 equals 3y. Then divide both sides by y minus 1. So x is equal to 3y over y minus 1. And so it can be undefined if y minus 1 is equal to 0. So y equals positive 1. Y must not equal to positive 1. So our range for letter A must be y, such that y is an element of real number where y must not equal to 1. Okay, I think that's all for week 2. And I was trying to do my best to discuss to you all the lessons for week 2. It's also hard for me to find the strong connection for the signal and also to write down using my hands. And I feel that my palms are numb. I feel that my arms are numb already. But I hope that you have learned a lot from me. Congratulations, we've done our week 2 and I hope I have helped you. Okay, so thank you for watching. And for week 3, for you to be updated, you can subscribe to my channel, Ma'am She. Okay, thank you so much for being with me and for watching my video. This is only a help or just a supplementary video, supplementary material to help my students from Kalinog National Comprehensive High School. And also it is open to help other students. And take note, if you have your corrections, okay, if you have your corrections to my videos and to my solvings, you can just comment down and correct it so that other people will know if I have some solutions that I have mislooked. So I am very open for suggestions. I am very open for criticism so that I can improve my future videos. I hope you would understand that we teachers really find it hard to cope with this new normal, but we are trying our best to help you guys. Thank you for watching and goodbye. See you on week 3.